this ratio will be equal to 10 to the power of 0.753, which is equal to 5.66. 5.66. So this is this. So I can write that the concentration of ethanoate ions is equal to 5.66 times the concentration of ethanoic acid. So this is the relation that I can derive. Now I know that volume is basically nothing but it is concentration times. So if I reduce the relationship between N is equal to C over V, right? So if I reduce the relationship, then I know that N times C is equal to concentration. N times V is equal to concentration. So I think I've made a slight mistake over here. Yeah, I made a slight mistake. N is equal to C into B. So I can say that. So first of all, I have first of all I know that 5.6 that the concentration of ethanoate ions is 5.66 times the concentration of ethanoic acid. So the total volume has to be 100. So if I take the volume of ethanoate ions as X, no sorry, not ethanoate ions, but if I take the volume of ethanoic acid as X, if I take the volume of ethanoic acid as X, then I know that the total volume is X plus 5.66x, because the volume of ethanoic acid times the volume of ethanoate ions. So 5.66x is equal to 100. So I can say that X is equal to 100 over 5.66 plus 1. This is simple algebra, and what I get from this is 15. So I get X is equal to 15.0 centimeter cube. So I get X as 15.0 centimeter cube, and the total volume is 100. So the total volume is 100 and the volume of ethanoic acid is 15.0 centimeter cube. So the volume of sodium ethanoate has to be 100 minus 15, which will be obviously 85.0 centimeter cube. And that's how we get to the answer. And that is it. So this is it for this question. Let's move to the next one. Now, solutions of hydrogen phosphates make useful buffers for biochemical experiments. Explain what is meant by the term buffer solution. So a buffer solution is one that resists change in its pH upon the addition of small amounts of acids or bases. This is the definition that I gave you for buffer solution. Then calculate the pH of a buffer solution that contains 0.20 mole per dm cube of NaH2OPO4 and 0.10 mole per dm cube of Na2HPO4 negative. So first let's write some equations. So NaH2PO4 negative. So if you first look at which one will be the acid, because the acid will be the one with more number of H plus ions. So I can see that I have two hydrogens over here, and I can see that I have only one hydrogen over here. So I know that my weak acid in this case is NaH2PO4, which will dissociate to form, because it has an extra H plus, so it will dissociate to form NaHPO4 negative plus H plus. And then I have the second one, which is my conjugate, a salt of my conjugate base. So my conjugate base here is NaHPO4 negative. So this is basically NaHPO4 negative. The salt which I'm using is NaHPO4